Whether you're a tech enthusiast, industry professional, or just curious about the future of AI Agents Unleashed will keep you informed and inspired. Buckle up and get ready to unleash the potential of AI.
Welcome to another deep dive. Today, we're going to be exploring AI agents.
Okay.
Specifically, ones that use language to interact with tools and solve problems.
Sounds good.
These are called language agents.
Right.
And they're causing quite a stir because unlike traditional AI, they can adapt to a wider range of tasks.
Yeah, exactly.
What's even more fascinating is their potential in science.
Hmm.
Imagine AI analyzing data, using tools, and even conducting experiments all through language.
Yeah, it's like having a tireless digital lab assistant at your fingertips.
Oh, wow.
And what we're diving into today is the Aviary framework.
Okay.
A sort of training ground where these language agents are put through their paces on complex, realistic problems.
So like a boot camp for AI.
You could say that.
And here's the kicker. Aviary uses open source language models.
Yeah.
Which are smaller than some of the big names out there,
right,
but still deliver impressive results. But how do these language agents actually learn to solve such complex scientific problems?
That's where the language decision process, or LDP, comes in.
Okay.
Imagine a choose-your-own-adventure game where the agent observes the situation, makes a decision based on what it sees, takes action using a tool, and then receives feedback. All of this happens through language.
Okay, I'm starting to see how this works.
What?
But I have to admit, the idea of a stochastic computation graph to visualize this process sounds a bit intimidating.
Right.
Can you break that down for us?
Sure.
Thanks.
Think of it like a flowchart.
Okay.
With a bit of randomness thrown in.
Okay.
At each step, the agent makes a choice based on probabilities, making its decision-making less predictable but potentially more flexible.
So more adaptable.
Yeah.
Gotcha.
This cycle of observing, acting, and receiving feedback is at the heart of LDPs, allowing agents to refine their strategies over time.
So it's not just one size fits all.
Exactly.
There are different ways to architect these agents, right?
Right, absolutely.
Okay.
There's a whole spectrum of complexity when it comes to how these agents are designed.
Oh, I see.
Some rely solely on a language model to make decisions, kind of like a student using their knowledge to answer a test question.
Makes sense.
Others use retrieval methods to access external information, much like a detective searching a database for clues.
Gotcha.
And some even employ rejection sampling, which is like brainstorming multiple solutions and picking the best one.
Interesting.
Yeah.
It's amazing how much thought goes into designing these agents.
Yeah, it's a really fascinating field.
But let's move on to the environments where these language agents are put to the test in Aviary.
Okay.
I'm especially intrigued by those that focus on scientific research.
Yeah, there are 5 diverse environments, each designed to mimic real-world challenges. And several of them are pushing the boundaries of what's possible in science.
So tell me more about these environments.
Okay.
I'm ready for a tour.
Well, first up, we have GSM-8K. This one focuses on solving grade school math problems.
Sounds easy enough.
But don't underestimate it.
Okay.
These problems involve multi-step reasoning and require the agent to use a calculator tool.
So it's not just about basic arithmetic.
Exactly.
It's about testing the agent's ability to break down problems and use tools like a young scientist tackling their first experiment.
Right.
Cool.
Then there's TPOTQA,
where
the agent has to answer trivia questions by searching Wikipedia. It's like a digital detective, figuring out which articles are relevant and sifting through them to find the answer.
That sounds challenging.
It is.
Talk about information overload.
Yeah.
And what about those environments that are really pushing the boundaries in science?
Now we're getting to the really interesting stuff.
Okay, I'm all ears.
Let's talk about paper QA2, local.
Okay.
In this environment, the agent needs to answer complex research questions by digging through a mountain of scientific papers using a semantic search tool. Imagine having an AI that can summarize key findings from dozens of research papers in seconds.
That's incredible.
It is.
It's like having a superpowered research assistant who can analyze and synthesize information from tons of sources.
Exactly.
I can already see how valuable that would be.
Yeah.
But what about the other scientific environments?
The next one is molecular cloning, where the agent actually designs and manipulates DNA sequences.
Wow.
It has to understand the biology, plan experiments, and use tools to manipulate the DNA.
Wow.
Just like a scientist in a lab.
It's like a digital geneticist.
Yeah.
That's amazing.
We think about the implications.
Okay.
A language agent designing gene therapies or creating new biofuels. This is the kind of future molecular cloning could unlock.
Wow, that's a game changer.
It is.
It seems like we're on the verge of a scientific revolution with these language agents.
It's definitely an exciting time to be working in this field.
And last but certainly not least, we have protein stability. This is where the agent has to engineer proteins to be more stable.
Yes.
It analyzes the protein structure, proposes mutations using sophisticated software, and delves into the complexities of protein engineering.
Exactly.
This has enormous implications for drug design and bioengineering, doesn't it?
Absolutely.
It's like having a tiny digital bioengineer working tirelessly to improve medicines and therapies.
Precisely.
So we've seen the amazing environments where these agents are trained.
Right.
But how do they actually learn to tackle these complex tasks?
Well, there are several approaches.
Okay.
One way is through behavior cloning, essentially learning by example.
Okay.
The agent is given successful examples of how to solve a problem, and it tries to imitate those strategies.
So it's like learning from a master chef by watching them work and trying to replicate their techniques.
Precisely. That makes sense. But to really take the learning process to the next level, we have expert iteration.
Okay, I'm intrigued.
Tell me more about expert iteration.
Yeah, tell me more about expert iteration.
Think of it like this. The agent is given a problem to solve on its own.
Okay.
But if it fails, it's not the end of the world.
Right.
Instead, it gets feedback on what went wrong.
Okay.
Learns from its mistakes, and tries again with a refined approach.
So it's constantly learning and improving.
Exactly.
That's a fascinating way to approach learning.
Yeah, it's a really powerful technique.
It encourages the agent to become more independent and adaptable.
It does.
But what about ensuring accuracy? How do they make sure the agents are producing reliable results?
Well, one technique the researchers use to boost accuracy is called majority voting.
Okay.
Imagine running the agent multiple times on the same problem,
Yeah.
and then simply choosing the answer that appears most often.
Gotcha.
This is similar to how scientists repeat experiments multiple times to verify their results.
That's a great analogy.
Thanks.
Makes perfect sense.
It's a clever way to leverage the power of repetition to improve accuracy.
So you're saying that by running the agent multiple times and seeing which answer comes up most frequently, they can boost the confidence in the results.
Exactly.
Okay.
And what's remarkable is that by using this technique with a relatively small language model, they were able to outperform much larger commercial models in some cases.
Hold on. You're saying that a smaller open source model actually beat a larger, more expensive model?
Yeah.
That's surprising.
It is.
I would have thought bigger was always better when it comes to AI.
That's a common assumption, but it's not always the case.
Really?
Yeah, this research really highlights the power of smart training techniques and efficient design. It challenges the idea that you need the biggest, most expensive AI to get the best results.
This brings up an important question.
What's that?
What about the cost of all of this?
Right.
Training these powerful agents must be incredibly expensive, right?
It can be.
Especially when compared to those smaller open source models.
Yes, where things get really interesting.
Okay, I'm listening.
When you compare the cost of running a large commercial model like Claude 3.5 Sonnet to a smaller model like Llama 3.1 Adagi,
Okay.
the difference is significant. We're talking potentially orders of magnitude cheaper.
Wow, that's a huge difference.
It is.
So it's not just about accuracy.
Right.
It's about finding the sweet spot between performance and affordability.
Exactly.
Especially for researchers with limited budgets.
Absolutely.
So it's like finding a hidden gem, a powerful tool that's both effective and affordable.
It is.
What's not to love about that?
That's a win-win situation.
It is.
And it opens up exciting possibilities for democratizing access to AI, allowing more researchers to leverage these powerful tools.
This is all so fascinating.
It is.
It seems like we're on the cusp of a major revolution in scientific research,
Yeah.
thanks to the power of language agents.
Absolutely.
But I have to ask, what were some of the specific results these researchers achieved?
Okay.
Did these smaller open source models really hold their own against the commercial giants?
Well, let's dive into their results and see.
Okay, sounds good.
They chose tasks with clear benchmarks, so they could directly compare the performance of various language agents
Right.
and even human experts.
Right, to see how they stack up.
Exactly.
Okay.
2 tasks stood out. CQA, which we talked about earlier with the molecular cloning environment.
Yeah.
And LitQA2, which involves answering questions based on scientific literature within the paper QA environment.
So it's like a head-to-head competition.
Kinda.
To see who can answer these complex scientific questions most accurately.
Exactly.
What were the results?
Let's start with LitQA2.
Okay.
The researchers found that using majority voting with the Claude 3.5 Sonnet agent led to an impressive 89% accuracy on the test set.
Wow, that's really good.
Yeah, it was a major improvement over previous scores of 67%.
Okay.
And even surpassed human performance.
Wow, so the AI is actually outperforming humans on this task.
On this particular task, yes.
That's pretty impressive.
It is.
But I'm still curious about the smaller llama model.
Right.
How did it perform in comparison?
Well, the llama-based agent, even with expert iteration and majority voting, couldn't quite reach that same peak performance on LitQA2.
Okay.
It actually outperformed the Claude agent when only a single run was allowed.
Wait, are you telling me that a smaller open-source model running just once beat a much larger, more expensive commercial model?
That's exactly what I'm saying.
That's incredible.
It is.
It seems counterintuitive.
It does.
Especially if we're assuming bigger is always better.
Yeah, it challenges that assumption.
Right.
And demonstrates the power of clever training techniques and the efficiency of the LDP framework.
So it's not just about brute force power.
No, not at all.
It's about using the right tools and techniques for the job.
Exactly.
This is really exciting.
It is.
It seems like the playing field is being leveled.
In a way, yeah.
Allowing researchers with limited resources to potentially achieve comparable results to those with access to much larger, more expensive models.
Yeah, that's one of the most exciting aspects of this research.
Absolutely.
It has the potential to democratize access to AI.
Now, what about CQA?
Okay.
The task that involves manipulating DNA sequences.
Right.
How did the models perform on that one?
On CQA, the llama-based agent really shone.
Oh, wow.
Even with a single run, it achieved an accuracy comparable to human experts.
Okay.
And the best previously reported results?
Yeah.
And when they used majority voting with hundreds of runs, the accuracy jumped to 89%, exceeding even the Claude agent.
So the open source model not only wins on efficiency, but also claims victory on accuracy for this specific task.
On this one, yeah.
What might be the reason for this superior performance?
Well, it's likely due to the nature of the CQA task itself. Like, it requires a longer, more consistent chain of tool calls compared to LitQA2, which might play to the strengths of the llama agent, as it's specifically trained to excel in these multi-step reasoning scenarios.
So it's like the llama agent is a marathon runner.
Yeah.
While the Claude agent might be better suited for sprints.
A good analogy.
Each has its strengths, depending on the challenge at hand.
Precisely.
But let's move beyond just benchmarks and talk about real-world implications.
Sure.
We're talking about potentially automating complex scientific tasks, accelerating research, and maybe even making groundbreaking discoveries that wouldn't be possible without these advancements.
Absolutely.
It's exciting to think about the potential.
It is.
Imagine a future where AI collaborates with scientists, analyzing data, designing experiments, and generating hypotheses at an unprecedented pace.
It's really quite mind-blowing.
The possibilities are truly exciting.
They are.
And let's not forget the cost savings by using open source models and clever techniques like expert iteration and majority voting. Researchers can achieve remarkable results at a fraction of the cost of using commercial models.
Exactly.
This opens up so many opportunities for researchers who might not have access to those larger, more expensive resources.
That's right.
It's like we're witnessing the birth of a new era in science.
I think we are.
Where humans and AI work together, each contributing their unique strengths to solve some of the most challenging problems facing humanity.
It's a truly inspiring prospect.
It is.
But speaking of challenges, let's shift gears a bit and talk about another fascinating environment within Aviary, protein stability. You mentioned earlier that this involves engineering proteins to be more stable, which has huge implications for fields like drug design and bioengineering.
Yeah, that's right.
And this is a great example of how AI can be combined with traditional scientific methods to achieve remarkable results.
Okay.
In this case, the researchers used a technique called oracle verification.
Oracle verification?
Yeah.
Okay, I'm intrigued.
how does oracle verification work in this context?
Yeah, tell me more.
Imagine you're trying to find the best mutation to make a protein more stable.
Okay.
You could use the language agent to generate a bunch of candidate mutations.
Uh-huh.
Then, instead of relying solely on the language model,
Yeah.
you use a separate independent method to actually test those mutations.
Okay.
In this case, they used the Rosetta software, which is a powerful tool for protein modeling and analysis.
Right.
It's like having an expert panel evaluate each candidate and provide a score based on its potential.
So the language agent proposes the ideas.
Right.
And the oracle, in this case Rosetta, determines which idea is the most promising.
Exactly.
It's a collaborative process that leverages the strengths of both AI and established scientific methods.
That's a great way to put it.
The researchers found that by using oracle verification with multiple runs of the language agent, they could significantly improve the chances of finding a truly stabilizing mutation.
That's right.
It's like casting a wider net and then using a fine-tuned filter to catch the best fish.
I like that analogy.
And this combination of AI and traditional methods seems to be pushing the boundaries of what's possible in protein engineering.
It really is.
It's really amazing to see how these different approaches are being combined to solve complex problems.
It is.
It's also important to remember that AI isn't meant to replace human scientists.
Absolutely not.
It's a powerful tool that, when used in conjunction with human expertise and established methods, can lead to breakthroughs that wouldn't be possible otherwise.
I completely agree.
It's all about collaboration.
Yeah.
And finding the right balance between human ingenuity and AI's computational power.
A powerful partnership indeed.
Now let's zoom out a bit.
Okay.
Consider the bigger picture.
Sure.
We've discussed some impressive achievements of language agents.
Right.
From solving complex scientific questions to designing stable proteins.
Yes.
But what does it all mean in the grand scheme of things?
That's a good question.
What's the takeaway for our listeners?
We're seeing a clear trend.
Okay.
AI is becoming increasingly capable of understanding and manipulating complex scientific concepts.
That's pretty remarkable.
It is.
This opens up incredible possibilities for accelerating scientific discovery, automating tedious tasks, and potentially even leading to breakthroughs that would have been impossible for humans to achieve alone.
Exactly.
It's like we're entering a new era of scientific exploration.
It certainly feels that way.
Where the boundaries of what's possible are constantly being pushed further and further.
Right.
And with the added benefit of potentially significant cost savings through the use of open source models. It seems like the future of scientific research is incredibly bright.
It does.
But I know there's always another side to the coin. Are there any potential downsides to consider with this rapid advancement in AI technology?
That's a great question. And it's important to acknowledge that while the potential benefits are vast, we also need to be aware of the potential challenges. One of the key concerns is ensuring responsible development and deployment of these powerful AI tools.
So it's not just about creating these amazing technologies,
right,
but also about ensuring they're used ethically and for the betterment of humanity.
Precisely.
We need to be mindful of potential biases in the data used to train these models, as well as the potential for misuse.
That's right.
It's crucial that we develop robust ethical frameworks to guide the development and application of AI in science and beyond.
I completely agree.
That's a crucial point.
It is.
It's not enough to simply focus on the technical advancements.
No.
We need to consider the ethical implications as well.
Yeah.
We want to make sure that these powerful tools are used for good and that the benefits are shared widely.
Absolutely.
And speaking of sharing benefits widely, let's come back to the cost effectiveness of open source models.
Okay.
The researchers provided concrete evidence for the cost savings associated with using the Llama 3.18b model compared to the commercial Claude 3.5 Sonnet model. They compared the cost of achieving the same level of accuracy on the CQA and LigQA2 tasks.
Okay.
Okay, I'm all ears.
Sure.
Let's talk numbers.
Let's do it.
How much cheaper was the open source approach?
For the CQA task, using the Llama-based agent could achieve the same level of accuracy at a cost that was 100 times less than using the Claude model.
Wow, that's a staggering difference.
It is.
It makes you wonder why anyone would choose the more expensive option when there's such a cost-effective alternative available.
Well, I know, right?
What about the LigQA2 task?
While they couldn't quite match the peak performance of Claude on the LitQA2 task,
Right.
the Llama agent still outperformed the single-run Claude agent, while costing 3 times less to operate.
So even though it didn't reach the absolute peak performance,
Right.
it still outperformed the more expensive model in a head-to-head comparison while being significantly cheaper to run.
Exactly.
That's a remarkable achievement.
It is.
And really underscores the potential of open source models to democratize access to these powerful AI tools.
It really does.
It's like finding a hidden gem, a powerful tool that's both effective and affordable.
Yeah.
This opens up exciting possibilities for researchers all over the world, allowing them to leverage the power of AI without breaking the bank.
Absolutely.
It's a game changer for scientific research, fostering a more inclusive and collaborative environment where innovation is accessible to a wider range of individuals and institutions.
Couldn't have said it better myself.
And as we've seen, this collaboration between human ingenuity and AI's computational power is already yielding impressive results.
Yeah, it's really exciting to see where this all leads.
It's like witnessing the dawn of a new era in science.
I think so too.
But with any powerful technology,
Right.
there are always ethical considerations that we need to be mindful of.
Of course.
How do we ensure that these AI tools are used responsibly?
That's the big question.
How do we prevent misuse and ensure equitable access for everyone?
Those are the challenges we need to address as we move forward.
It's fascinating to see how rapidly this field is advancing.
It is.
But it's also important to acknowledge that there are limitations to what we've discussed so far.
Right.
These benchmarks in controlled environments,
Yeah.
while impressive, don't necessarily capture the full complexity of real-world scientific research.
That's a good point.
It's like the difference between practicing in a flight simulator and actually flying a plane.
I see what you mean.
There are so many variables and unexpected situations that you can't fully anticipate or replicate in a controlled setting.
That's true.
What other limitations do the researchers highlight?
Well, another important point they raised is the difficulty of directly comparing the performance of language agents to human scientists.
Right.
They each have unique strengths and weaknesses, making it challenging to conduct an apples-to-apples comparison.
Right. Humans bring qualities like creativity, intuition, and a deep understanding of the scientific process that are difficult to program into an AI.
Those are really challenging things to capture in an algorithm.
While AI excels at processing massive amounts of data, identifying patterns, and performing complex calculations at speeds that humans can't match.
Exactly.
So it's not about replacing human scientists with AI.
No, not at all.
But rather about augmenting their capabilities. And creating a synergy between human ingenuity and AI's computational prowess.
That's the goal.
Each has a unique and valuable role to play in advancing scientific knowledge.
I agree.
It's about recognizing that AI is a powerful tool that can enhance and accelerate scientific discovery. When used in collaboration with human expertise. This idea of humans and AI working together is really exciting.
It is.
What does that future look like?
Imagine teams of scientists working alongside AI agents, each contributing their unique strengths to tackle some of the most pressing scientific challenges.
So like a true partnership.
Exactly. The AI could analyze massive data sets, identify promising research avenues, and help design experiments.
Interesting.
While the human scientist could provide the intuition, critical thinking, and domain expertise needed to guide the research and interpret the results.
That's a compelling vision.
It is.
It's like assembling an all-star team where each member brings their A game to achieve something extraordinary.
I like that analogy.
This research has given us a glimpse of what's possible when we combine the power of AI with human ingenuity.
It really has.
It's truly a transformative moment in science.
It is.
We're witnessing the development of tools that have the potential to revolutionize the way research is conducted and accelerate the pace of discovery.
And it's only the beginning.
Well, I think it's safe to say that our deep dive into the world of language agents has left us feeling both informed and inspired.
I hope so.
We've explored a revolutionary framework for training these agents. Discovered how they're being used to tackle complex scientific challenges, and witnessed the remarkable power and affordability of open source models.
And we've only just scratched the surface.
And perhaps most importantly, we've caught a glimpse of a future where AI empowers scientists, accelerates discoveries, and helps us address some of the most pressing problems facing humanity.
It's an exciting time to be alive.
It is.
A future filled with both exciting possibilities and important ethical considerations that we must navigate thoughtfully.
It's an incredible journey that we're all on together.
It is.
This journey into the world of AI has been remarkable.
I agree.
As we conclude our deep dive,
Okay.
let's leave our listener with a question to ponder.
I like it.
What does this rapid progress in language agent technology mean for the future of scientific research? Will we see language agents making groundbreaking discoveries alongside human scientists, pushing the boundaries of knowledge further than we ever thought possible?